In this episode, we will review three special kinds of angle pairs and talk about how the relationships change when lines are parallel or when lines are not parallel. The first angle pair to review from our last class is called alternate exterior, and angle A and angle H are an example of alternate exterior. They're alternate because they are on different sides of the transversal, and they are exterior because they are outside of the two lines. So they're on the exterior of the two lines. Another example of alternate exterior angles, angle B is alternate exterior with exactly angle G. So these are alternate exterior, A with H, B with G. Now for us to look at alternate interior, well, there's an angle that is alternate interior with angle E. Now on the interior, in between the two lines, still alternate on the other side of the transversal. So go over the transversal. So E and D are alternate interior. The other example must be F from the interior, then alternate on the interior is C. E with D, F with C are the alternate interior. There are four pairs of corresponding angles. Corresponding angles are found in the same position at a different intersection. So for example, angle A is in the upper left at this intersection. So to be in the same position would again be in the upper left. So A and E are corresponding. Which angle is corresponding with angle C? Angle G. Which angle corresponds with angle H in the lower right? Angle D. And finally, angle B corresponding with angle F. So we've gone over alternate exterior, alternate interior, and now corresponding as the three types of special angle pairs when we have two lines cut by a transversal. Okay, so we're going to do an example where our lines are not parallel. And I hope you can see that line L is not exactly parallel to line M. You should see that they're coming closer together as we move down to the right, and they would intersect somewhere down here. And if we need to give evidence, and that's what we need to do in geometry, give evidence using the angle measures that they are not parallel, here's how we would do that. So I measured these angles when I drew the lines, and angle A is about 45 degrees. And angle E is about 50 degrees. So I can, and then if I think about the positions, angle A and angle E are both in the same position. They're in the upper left, and we call that corresponding angles. So we could say, since corresponding angles are not congruent, congruent meaning having the same angle measure, L is not. So since they are not congruent, L is not parallel to M. Now, we talked in previous lessons about how intersections will be identical when the lines are parallel. So let's fill in the rest of the intersections So we know all of the angle measures. So that involves some subtracting from 180. I'm going to do the bottom intersection first. So I know that vertical from angle E is angle H, and they have the same angle measure because vertical angles are congruent. So these are both 50 degrees. Then if I do subtracting from 180, I can say 180 minus 50 equals 130. So that tells me that angle F is 130 degrees and angle G is 130 degrees. Now to just finish off our evidence, if we look at the top, we want to deal with the 45. So now angle A and angle D, again, are vertical. So they have the same angle measure. They're congruent, 45 degrees. Then if we subtract from 45, then we get 135. So that allows us to say that angle B and angle C are 135 degrees. Again, we have evidence that L is not parallel to M because the intersection on top, where we have 45s and 135s, is not identical to the intersection at the bottom where we have 50s and 130s. So this is our evidence that these are not parallel. Finally, we would know enough if we just had what we started with. So as soon as we knew angle A was 45 degrees and angle E, was 50 degrees, we knew that L was not parallel to M because corresponding angles are not congruent. Since corresponding angles are not congruent, L is not parallel to M. So now I've made a new version of my two lines crossed by a transversal, where I made sure that angle E was 50 degrees like before, but now I also made sure that angle A would be 50 degrees. And that tells me that L and M now must be parallel. We can make sure we know that by filling in our other degree measures. So you might remember 50, 50, subtract from 180, give us 130, so 130. 130. And then again, the same math would apply up here because we're starting again with a 50-degree angle. So 50 vertical, 50. Linear pair, this is 50 degrees. Linear pair, 130 degrees, and linear pair, 100, and then vertical here, 130 degrees, like that. Sorry that the word is messy here. But you see that our intersections are identical. So we already know that corresponding angles are now congruent because L is parallel to M. So upper left, A and E are congruent. Upper right, B and F are congruent. Lower left, C and G. Lower right, D and H. Corresponding angles are congruent. Now let's see what happened with our other special angle pairs. So alternate exterior on the exterior of the lines and alternate from the transversal. So our 130s are congruent and our 50s are congruent. Our alternate exterior are not now congruent. This is what happens when lines are parallel and crossed by a transversal. Finally, let's go to the inside of the parallel lines. So 50 is interior and alternate interior with 50 here. So alternate interior angles are congruent, and we also see that with our 130s. Alternate, the other side of the transversal, interior, staying inside the two lines, are congruent. So now what we see is when two lines are parallel, they're special angle pairs. congruent. They have the same degree measure.